Hello, and welcome to the Spec Shaman Podcast, the show that explores the world of building product manufacturers, architects, and engineers, sustainable design, and technology and trends. We engage in thought-provoking discussions with renowned experts, industry pioneers, and visionaries who are making a significant impact in the construction industry. Join us as we explore groundbreaking ideas, revolutionary concepts, and the latest advancements shaping the built environment. I hope you enjoyed this week's episode. Let's get started.
Hi, and welcome to the Spec Shaman Podcast. I'm your host, Megan Vipond. I'm joined today by Larry Aker, CTO at ACT on Demand Control Systems. He is here to discuss the connection between water and energy, as well as the implementation and performance of hot water systems. Hi, Larry. Welcome to the Spec Shaman Podcast.
Hey, good morning, Megan. Pleasure to be here. Thank you for allowing me to be on part of your podcast.
Yes, thank you. Now, Larry, before we get started here, can you tell us what inspired you to get involved in the conservation of water and energy?
Well, I guess we could start by saying that I was actually an environmentalist from an early age. I spent a lot of time in the Rocky Mountains and the Pacific Coast Range, living off the land, if you want to call it that. I enjoyed the fishing trips and the backpacking trips and those kinds of things. And I realized after a few years that we could no longer drink the water that's coming out of the lakes or out of the streams in high elevations, like 10 or 12,000 feet elevation. The reason? Because of the pollution factors that occur coming from the rains and other pollutions that actually created a problem with that freshwater supply. I started working with water issues back in the 80s when I realized that there is a tremendous limitation of amount of fresh water. There's less than 8 or 9% of the fresh water that's really available to us. Most of it is in the North and South Poles, which is not available to us. And as our population grows, it's just amazing the amount of water that is not available, that's potable water, fresh water for the people to use. And I'll give you an example of that real quick. Today, there's over 2.3 billion people living in water-stressed countries, and there's 1.42 billion people, including 450 million children, that live in area high or extremely in high water vulnerability, which means that it's not potable. It has to be boiled, or they're drinking water that's really not good for them. And there's over 4 billion people experience severe water scarcity during at least 1 month out of the year. Considering that, back in the days of the 80s, I realized that we had to do something about our water supply, especially in North America or in the United States. And that's how I got involved. I started working with the agencies, the water agencies, and other folks that are actively involved in trying to save water. And I suddenly realized that saving water wasn't exactly the main goal of the water agencies. It's an income factor to them. It's economic motivation. So they really weren't trying to consider saving water. They talked about it, but they didn't do much about it. And the cost of water, even in the United States today, is way below what the value should be. It should be a lot higher for us, so we really considered saving it. I mean, as an individual, we just take water for granted, and that's not what we should be doing. That's how I actually got involved with the water conservation side of it. It wasn't until the late 80s and 90s, early 90s, that I got involved with the energy side of that water and the other aspects of what water really pertains, and the energy factors and the other issues that are environmentally involved. That's how I got involved. And as we get into this podcast, I can get into more of the details of why that water is so important, not just from water supply, but from the other factors, including air pollution, energy, and other facts that are critical that we should learn more about.
Absolutely. So you have a very long history and a lot of knowledge in this area. What ways does that wasted water also represent wasted energy?
Well, I wasn't aware of this until probably the mid 90s when I realized that I started doing a lot of research on water and heating and the facts that deal with those areas. And I found out that heating water takes more energy to heat water than any liquid or solid in the world. I did not know that. I mean, it takes a lot of energy to heat water. So we heat water from, let's say, an incoming water supply of 50 degrees or 55 degrees on an average. We heat it to 120 degrees. Doing that represents a tremendous amount of energy. So you don't want to waste that water, not just from the water itself, but from the fact of the energy that it creates. And for every 5 or 6 gallons of water that's been heated that you run down the drain, represents 1 kilowatt hour of loss. 1 kilowatt hour represents 1.5 pounds of carbon dioxide. And we'll get into a little more of the details of why that's so critical, because the average homeowner in the United States loses between 8 to 12,000 gallons of water a year just waiting for hot water, which means all of the water they're running down the drain represents energy because it's all heated water or preheated water. So that's really the key. And if you look at those numbers, let's average 10,000 gallons a year per household, you're looking at somewhere in the area of 10,000 gallons would represent about 350,000 kilowatt hours. And that would represent somewhere about 5,000 pounds of carbon dioxide. And that is one heck of a lot of pollution just from saving a few gallons of water. So that's my take on wasted energy and how significant this term of environmental impact is, because it impacts virtually all phases of our environment: energy, water, the pollution, meaning the air quality, but even more important, the processing. You're losing potable water by the thousands of gallons per household. You're losing potable water that's going into your sewage system, which now has to be processed. And that is a huge expense. And mostly, if you look at a lot of the areas across the United States, you're going to find that our processing plants are overwhelmed and they're actually they're not very functional in a lot of cases. We dump millions and millions of raw sewage into the oceans and lakes every year because they don't have a way to process all of that waste. So why would you want to put thousands of gallons of potable water in with the sewage water that's going to have to be processed?
Absolutely. So it sounds like water usage and energy consumption are very much directly linked in a lot of areas, but especially in hot water delivery. What are some common insufficiencies then in traditional plumbing and HVAC systems that may contribute to furthering that water and energy waste?
Well, let's take just homes in general. If you go back in the 50s, when they started first developing what I call production type homes after the war, the homes that your parents lived in or your grandparents lived in may have had 5 hot water fixtures. Today, the homes average 15 to 18 hot water fixtures. So we've multiplied our hot water fixtures without taking into consideration how we use water or hot water. And why? It's because it's so inexpensive. We don't think about it as a homeowner. We know we turn a faucet on, we get water. Now we do get unhappy when we have to wait for the hot water. So typically none of us do. Your parents didn't. I didn't. My parents didn't. So we just let it run. We'll go in the other room and go out and feed the dog or make coffee or whatever. Uh, so when we come back, we've not only got hot water waiting, it's probably been running for a matter of minutes.
So, what strategies then or technologies can help reduce the waste of that water and energy in residential and maybe even commercial buildings?
Well, because water is reasonably inexpensive, and we don't really think about the cost of it because we get a bill and it's not much, so we don't worry about it. The problem is that when they build new homes, and because a lot of the people going to be listening to this podcast are actually going to be architects who design buildings, whether they be residential or commercial, uh, we haven't designed our plumbing like we do everything else in the home. The strategy of the plumbing was always okay, we got a water heater someplace in the house and we've got lines that go out. And so the plumber literally just plumbs it the best way he knows or the easiest way he knows to get water, both cold and hot water, to the fixtures. The problem was that uh, within the last few years, the codes have required us to start having what we call low flow fixtures, meaning you can no longer get 3 or 4 gallons per minute out of a fixture. It's getting even worse. They're reducing the size of them down to half inch or 3/8 of an inch on short runs, which eliminates the ability for water to move quickly through those pipes, which means we not only waste more water, but we also are going to waste the energy to get that hot water to the fixture. So the fact is that we've put in low flow fixtures, which create a major problem of getting that water supply to our fixtures. And two, we've put in larger pipes because now they're based on the number of fixtures that you have. So the more fixtures you have, the larger the codes require the pipe to come out of the water heater. So it's a kind of a catch-22. You're filling up a large pipe and then you're bringing it down to a very small pipe going into the fixtures. And at the same time, you've reduced the ability to make that flow come quicker by simply putting in low flow fixtures that won't allow the water to flow through. So no matter what your head pressure is or your pressure is coming in from the outside, your outside water pressure, it's restricted by your fixtures alone. So what you need to do, and our problem is we need to train the industry, the contractors and the builders and the architects to be able to plan this, to put the hot water supply closer to the fixtures. Now, there's several ways of doing that. You can do that by putting the water heater in the middle of the house and allowing short runs, so the runs aren't any more than maybe 15 feet away from the fixtures. That's not likely to happen because of the space that's required to do that. So what we need to do is we need to run the water fixtures, especially the hot water fixtures, so it literally goes by each hot water fixture in the home. And once you get hot water in that main line, the main trunk line, your fixtures to hot water supply to the fixtures are very short. They could be within 5 to 10 feet. So you're going to get hot water when you turn your faucet on in a matter of 4 or 5 seconds. And that's the way we try to help design the plumbing to work that way. Now, the one thing that is important is there was no way of doing what we're going to be talking about until the late 80s, when we designed and developed what they call on-demand control systems and tested how we could manually or mechanically move water from a water fixture or from a heating source to a water fixture in a very short period of time on the demand of the user. The key to that was we needed to make sure it worked. We found a lot of different ways of doing that. The real important thing was that we had to make it work, and then we had to get the code. So we developed codes with IATMO, of International Plumbing Codes, the standards for on-demand control systems, as well as UL. UL had no standards for the electrical side of it either. So in 1995, these standards were established in the industry. Since that period of time, there have been a number of codes and regulations that have occurred in the United States that include both the water and energy savings using hot water on-demand control systems for the distribution.
Fantastic, Larry. Sounds like there's a lot of strategies and potential avenues to take when it comes to water and energy usage and conservation. Switching gears just a little bit into some of those fundamentals and the system designs, can you explain just the basic principles of hot water recirculation systems and how that could enhance efficiency?
Thank you. That's a good question. First, on residential homes, the best way to do it is to design, as I mentioned, design your plumbing so the main trunk line goes close to all of your hot water fixtures. And you can do that in several different ways. You can dead end your main trunk line by ending somewhere in the house at the last fixture, and you can put in a hot water control device that will actually transfer the hot water from the water heater to the back part of the home by moving the ambient water, the water that's currently in your line that's neither hot or cold, it's just ambient temperature. Hot and cold water line are going to be the same temperature after a period of time. That water on the hot water side is transferred, instead of running down the drain, is transferred back through the cold water side back into the water heater. So no water is lost getting that hot water to the fixture, which shuts off automatically, which we refer to it as a delta T, or a change of temperature. Now, on another way to do it on commercial buildings and residential is to put in what they call a dedicated recirculating line, meaning it's a loop. It goes from the water heater, and the main trunk line goes all the way around the house and back into the water heater on a return line. And that's what they call a main trunk line, which has a return to the water heater. That's a dedicated line. The key here is you make sure that dedicated line is actually within a few feet of all of your fixtures. So once you've put water into that dedicated line, the loop, you're going to be able to get hot water your fixtures in a matter of 3 to 5, 6 seconds. The commercial operations take these dedicated return lines and they put pumps on them that run 24/7. Because if you look at a building like a Holiday Inn or extended stay hotel or boutique hotels, they operate water heaters that run literally 24 hours a day, meaning the pumps that pump the water out of the water heater cycles all the time. When you go out on your travels and you go into a hotel room or a restaurant, wherever, where they're using hot water constantly, you're going to be able to get hot water into the fixture on a very short period of time, no matter how big the building is. That's because they've got a main loop that runs 24/7. That is not a good idea. The reason is because when you're running hot water 24 hours a day, the reason they do it is because they don't know when people are going to use it. So they let it run 24 hours a day. Some of them put them on timers. Timers are not a good thing because you can never regulate the exact time people are going to use hot water. And the other reason for loop systems that run full time, 24 hours a day, they start degrading the water supply line, whether it be copper or PEX or whatever the material is. It'll start slowly breaking it down. Why does it do that? It's because you have 90-degree angles somewhere in that building that are going to create a velocity effect that's going to start degrading the interior side of whether it's copper or whatever the material is, to the point where you're going to have pinhole leaks. And that's one of the major issues that a lot of the multifamily homes and hotels have is these repair problems where they get holes in the pipes. The hot water is not just the issue, it's the chemicals and minerals that we actually put in that water to make it potable to meet the EPA standards. A lot of those chemicals, like chlorine, for example, is very aggressive when you heat it up. And it will attack anything that's metal or plastic, it doesn't matter. And there are other minerals in there. So when you heat up any minerals, you have an effect that you don't have when you're just running cold water. And that's a main issue. So we look at designing controls that actually will reduce the runtime for commercial buildings, hotels, and even homes that are very large, to reduce the runtime of that pump up to 90 to 95% of the time, but still allow hot water to be there 24 hours a day. So we're not getting that aggressive response on hot water flow. How do we do that? There's a number of ways to do that. You do that by algorithms, sensing controls, and those are the ways that over periods of time that we look at developing to make that work and more efficient and more economic for these larger buildings that run 24/7. But there's only so many ways you can move hot water. One, you can have an instantaneous water heater under every fixture, which is not very efficient and totally not reliable over a period of time, because that means you could have failures in any one, which could create leaks and floods and other kinds of conditions. So the options are running from a water heating supply, like in your garage or somewhere in your home that's not exactly near your fixtures. So you got to design plumbing to make that work, and we call it structured plumbing, but that means you're simply designing your plumbing to meet all the needs of your fixtures in your home to get hot water when you turn a faucet on within a few seconds. I hope that answered your question.
Yes, absolutely. So, are there some key differences then between traditional hot water recirculation systems and on demand systems?
Well, there's not really. I mean, like I mentioned, there's only a few ways that you're actually going to move water from a water heater. And I say water heater because we're really looking at the energy side. When you're bringing in cold water, it doesn't matter how you actually plumb the plumbing for cold water, because it's literally always going to be cold. When you're doing it for hot water, you've got to design your plumbing specifically so you don't waste that energy to create that long wait for the homeowners. And most people that we've talked to over years, and I've been able to visit several countries. We worked with Australia. In fact, I've been a speaker in Australia on several occasions, in Mexico, and into Canada. I've been in Spain and Italy looking at the way they plumb, and virtually everybody kind of does it the same way as far as piping. The key is being able to get the water close to your use as a homeowner. And the only way you can do that is to direct the plumbing correctly. So the answer to the multiple plumbing complexities, there isn't very many that you can have. What we're trying to do is solve the problem of the homeowner. The key also is in the water heating. Depending on the water heater, also may have an effect on how you distribute that water, because you really got three factors that are involved. You've got a water heater that functionally and been tested to prove to be efficient. You've got fixtures that are low flow now throughout the house that are functionally designed to be efficient. But the thing that's missing is the distribution of the hot water from the water heater to the fixtures. That's where you lose your energy, you lose your water supply, and all the other negatives that run into it. So we've got to look at a better way of designing the delivery of hot water from a water heating source to the fixtures in that building. I think what's going to happen is every service plumber out there, every new home construction plumber out there, the architects, I think it literally starts with the architects. They have to design the home to be efficient on the way the plumbing design is laid out. And there's a number of ways of doing that. We'd be more than happy to help them with that design. There are a number of people in the country right now that are experts on hot water supplies that can answer those same questions that are independent. So there's sources they can get to that they can get answers that they can believe.
All right. So, Larry, you mentioned plumbing design and the location design of hot water heaters, but are there any implications on pump sizing on the performance and energy consumption of hot water systems?
That's an excellent question. One of the things that we studied for a long time was what was necessary to be able to pump the water from the water source, hot water source, to the fixtures. And what we learned is it had nothing to do with a gallon per minute flow. It's got something to do with what we call head pressure. And head pressure is what that does. It kind of overcomes any resistance in the line. So if you got 90-degree angles, it has a tendency to power around those angles. And because we're only moving water for a short period of time, on-demand control systems literally only displace the ambient water that's in the line with hot water one time, then it shuts off automatically. So you can run water faster one time because you're not really moving the hot water, you're just simply displacing the water that's in the line. In order to do that, you need what we call a high head pressured pump. And that pressure we found needs to be somewhere in the area of around 25 to 26 feet of head. What that does, I mean, you could have a gallon, pumps are sized by GPM, gallons per minute, and also head pressure. But the higher the head pressure, the better off you're going to move gallons per minute through a restricted line. Large pumps are typically higher head pressure pumps, but they're more expensive, they're heavier, there are more issues involved with those kind of pumps. So it was important for us to find, or any contractor to find, a high head pressured pump that's going to be less expensive and it's going to be very efficient because of the efficiency ratio. And there are companies that are making those pumps specifically. One of them, and I'll mention the name because they're well known. They're the largest pump company in the world, and that's Grundfos pumps. They're made out of in the United States. That was one of the things that I think is critical when you're building a product like this, because it does require a lot of research, a lot of engineering, and potential questions have to be asked. It should be made in the United States. I'm a firm believer in everything that can be made should be made in America. And we've stressed that from the very beginning. And it's important for us to have, as it is all manufacturers, to have those products available if they buy accessories for them, to have them also made in the United States. So pump sizing is very important, and there are ways of getting around that pump size now with a higher head pressure pump.
Fantastic. So, hot water isn't a super new concept, but what are the latest trends in recirculation system design that professionals should be aware of?
Well, I think the best, and that's a very good question because there are very few people, literally in the United States, that really recognize what an on-demand controlled system is. As I said, that's a generic term that's currently being used. The on-demand controls, literally, if you go to probably 75% of the United States, they couldn't explain what that even means. The contractors aren't trained for it yet. It's relatively new to the industry. I think the codes actually got ahead of the ability for education to all the plumbing contractors because the codes are mostly designed for what we call builders, new home builders, or new construction builders, whether they be commercial, residential, whatever. So the codes are required by those people, but they're not always picked up or approved by the state. In other words, there are national codes that say they need to look at controlling the hot water flow in any residential or any commercial building. But the codes are not what we call mandatory in every state. Each state can literally not do it or do it. It's not it's an option that they can have. It should be probably more mandated. In states like California, it is mandated. Washington, Oregon, the Pacific Coast, it's mandated. And it's, as you well know, when California does anything, it kind of spreads out over a period of time across the United States. The builders, like production builders, for example, like the Pulte's and the Lennars and Shea and those builders recognize these concepts, these new modern concepts, like on-demand controls. They use them where they're mandatory, but they don't always use them where they're not mandatory. The reason is because it's a cost problem. They add cost to the building, and I don't have to explain to you what's happening on the cost factors of some of the materials that the builders use, like lumber, steel, and aluminum, and things like that, not only due to the tariff, but also due just to the importing costs themselves. So that's part of the problem. Builders want to do the right thing, but they also have to look at the economic motivation of how they do it. As far as new products coming into the market, most of something that is new when it comes to water heating is in what we call the water heater itself, meaning they've come up with what they call heat pump electric water heaters now, trying to get away from fossil fuels, trying to get away from the gas area, because the more gas products that you have, more fossil fuels that you use create more of a atmospheric condition, which is a problem for the air quality, more HO2 or carbon dioxide. So they're trying to get away from that. So the energy factors of electric tank water heaters are now changing the way they make them. They're making heat pumps on the water heaters to create a faster recovery and also to save energy. The fixture manufacturers are trying to do the same thing. They're trying to save from the water side, but they're limited to what they can do because the code requires nationally they all have to be low flow fixtures. So they're kind of what they call a catch-22. They can't do much more than reduce the flow, but make them more efficient. In other words, have seemingly a higher pressure coming out of the fixtures, like shower heads, for example. If you reduce the shower head less than 2 gallons per flow, you feel like you're getting sprinklers. So they try to create a new head on their shower heads and fixtures to allow that to feel like it's a much higher flow. And some of them have some pretty good fixtures. They're relatively expensive, but they're available. The real key here is everybody's trying to do, especially the manufacturers, they're trying to do two things. They're trying to keep the product inexpensive as possible. They're trying to be ahead of the curve, which is hard to do if you're trying to keep it inexpensive because you got to create something new. And three, they want to be able to sell it to either the builder or the contractors or the customers, depending on how they're marketing. That's really the important thing. And that's what all they're after. But it's all about economic motivation. And every builder out there knows that if he adds a couple of $1,000s to the home, he's eliminating a lot of people that can qualify to buy that home. That's why we have very few first-time buyer homes right now, because they're not available price-wise for younger people.
So, Larry, let's switch a little bit to sustainability and efficiency. What are the environmental benefits of using a hot water recirculation system in terms of reducing the water and energy waste?
Well, we've covered that to a point, and that's a good point to bring up again. The environmental issues are several. Number one, water supply itself is getting less and less available to us. It's going to be a lot more expensive. So it's going to be on the minds of everyone. The hot water supply side is going to be critical because the energy factors that are involved with hot water mean that you got a number of factors. You've got wear and tear on your water heater. You've got wear and tear on your plumbing, your piping itself. If you lose that water by running it down the drain to get hot water, the energy factors now become even greater. You've got to deliver that water, number one. It's going to be delivered by cold water supply, outside source from your water supplier. They have to do a number of things that are very expensive as far as producing the water to meet the EPA energy quality. So there's a big cost factor in bringing that water to the home, even if it's cold. Now you're heating it, you're heating something that is the most energy heating inefficiency of any liquid in the world. So you don't want to heat much of it if you can help it. So you want to keep your heating source down. You're heating it in some type of water heater supply, meaning a water heater that's tankless or tank, it doesn't matter. And the longer that hot water stays in there, the more you're moving it through, the more costly it's going to be to maintain the service of that water heater. So you want to keep it there and not lose it. You don't want to keep trying to reheat water. So there's an energy factor there that's going to start from the very beginning, from the water supplier. Now all the water you run down the drain, it goes into a sewage processing procedure, which means you're now having potable water going into sewage, which has to be processed. And our processing plants nationally are having one heck of a time trying to keep up with the population growth. A lot of them need to be totally redone, but you can't just close down a sewage plant. That's part of the problem. And the more severe weather we have creates a bigger issue with the sewage processing plants because they become overrun with water supply that's coming out of the sky. And so it creates a different kind of a problem, which becomes an energy factor as well. And then, as I mentioned, the energy factors when it comes to the pollution side, we're talking about kilowatt hours. For every kilowatt hour represents 1.5 pounds of carbon dioxide. And so literally, if you're losing 10,000 gallons of hot water, getting to get hot water a year for every home, you can just multiply it out. And you're talking about literally millions and millions of gallons and millions of carbon dioxide that's being delivered to the air.
So, could retrofitting an existing building with a new system improve its efficiency?
Oh, absolutely. Because most of the buildings that are out there are typically plumbed from the what I call a wrong plumbing for the not a structured plumbing to resolve the transportation of the potable hot water. Retrofitting of any building is going to make it a lot more efficient. It's going to make it easier to maintain, less maintenance. But more important, it's going to create a atmosphere of environmental conditioning that the homeowner wants. The If you can develop a product that saves energy, water, sewage processing, air quality that people like to use, you're going to get 100% benefit. That's really the key. If somebody likes it because it's going to create an advantage to them, they're going to use it. And that's one thing about on-demand control systems. The people that have installed them literally love it. They no longer wait for hot water. And when something goes wrong, like let's say if lightning hits their house and their power goes out, they no longer have hot water. One of the first things they want to replace is the on-demand control system because nobody likes to wait. You can control large buildings that currently run recirculating systems to lose or drop the pump run time by up to 90%, which is a real savings on both energy and also on the maintenance issues that go along with running 24-hour loops.
Absolutely. So a lot of potential benefits then for reducing that wait time for hot water. Is there a way for design professionals to calculate the potential water and energy savings from installing one of these systems?
Well, there is, and there's a couple of areas, a couple of folks that are independent out there that can help calculate those numbers. But it's actually based on the building and how the plumbing's laid out. So each home is somewhat different. The plumbing is somewhat different. So to calculate it is difficult to be real accurate, but they're coming up with what they call averages that can be calculated. And one of the things that is being developed is a way to calculate the amount of hot water that you use daily. So even the homeowner can go to his computer and analyze what how much hot water he actually used for that day. And when he knows that, then he can calculate what the cost of heating that water is by his utility company. Can pretty much tell him, depending on what type of water heater he has, what he might be saving or spending in the cost of heating that water. And the other way is to calculate the amount of, if you've got a pump system running a circulating line, then you can calculate the energy loss as well. What we've done in the past is we've calculated, going back to 1995, the amount of gallons of water that's being saved, and we try to change that date, those numbers every 30 days. But the last reading was 158 billion gallons, 159 billion gallons of water that's been, and that's all hot water, by the way, that's been saved since 1995. And that only represents probably maybe 10% of the residential market because most of the people don't even know a product like this is available. That 159 billion gallons represents 15 billion kilowatt hours. And that represents 23 billion tons of carbon dioxide being put into the air. So you just take those numbers and calculate them out, and considering that represents less than 10% of the households in the United States, by calculating the way you're saving it can help not only the homeowner save energy, water, and money, but it also helps our environment overall.
So, how has the role of architects and engineers then evolved in response to the growing need for conservation?
I think every architect and every engineer out there, and including the builder, want to do the right thing. The industry are trying to build homes that are going to last 100 years. That's what the codes want them to do. The issue with that is to build a home that's going to last 100 years is rather expensive. So the builders are at a catch-22. They want to build a home that's going to last 100 years, but on the other hand, they got to make it affordable. They can't build a home and say, there it is, guys, it's going to last 100 years. Most people that are going to buy that home are going to say, well, I'm not going to be around for 100 years. I don't care. It's all about money. It's about money I put up front and money that's going to cost me to in payments and what it's going to cost me in maintenance over a period of time. Because they all know the utilities are not going to go down. They're going to go up. All electric, gas, water, sewage, it's all going to be calculated and it's going nowhere but up. So they've got to take that into consideration.
So switching gears a little bit here, technology, smart controls, it's something that we're seeing evolving around us in a lot of different areas. But what advancements in technology have specifically improved the efficiency of hot water recirculation systems?
Well, I think all what they call home automation systems are another form of looking at saving environmental conditionings for new buildings, whether they be residential or commercial. The reason for automatic controls is to make life easier for the homeowner that are buying these buildings or live in these buildings. And I'm all for home automation. I think the electronic shows that are in Las Vegas every year and have been there for I think some 25 years are all indications of what the environment's trying to do to environmentally make a sounder and safer and more healthy place to live. The Some of them are gadgets, a lot of them are, but I think the automation side of it, and that's including whether it be the electrical supply, meaning for appliances, or whether it be for hot water fixtures, whether it be for water heaters or products like on demand, all create this environmentally uh, sound direction that we need to go to make that home last longer, survive over a longer period of time, and also be economically suitable for the people that own them or are living in them.
So, what factors then should design professionals consider when specifying water and energy saving technologies?
They look at it depends on the builder. There are groups like that are called EBA, which are made up mostly of what they call builders that are more custom home orientated. They have a tendency to put more into their home because they can get more out of them because their clientele base is higher income. So they're putting in things like solar. They're putting in other kinds of devices that these people can actually afford to buy to begin with. But when it gets down to the norm, or what we call the average, you're looking at the production builders that are trying to meet the average of the economic value or what people are earning, the earning side of it. And that's a very difficult thing to do. So they can't always apply the newer technology that they know would be beneficial to those homeowners over a period of time because they're not going to sell the home. There are several production builders that are what they call making special homes. In other words, you'll see this occasionally with a number of the bigger builders. They're building one home that's a showcase that'll have all of these features in it. So they're making that home available to their customer clientele, but it may not be economically available for them. But they want them to see what is out there and what is available. And if they get a customer that can't afford it, then the customer will say, well, I can't afford that one, but put that I'll put that in there. He can pick and choose when he builds a home. But most production builders that I'm familiar with, and I work with all of them, they they're kind of in a catch-22. They got to build a home that's economical. They got to build a home that people can afford to qualify for, and yet they want to build a sound home that's going to last a long time. And all those things don't necessarily meet. So they've got to pick and choose what they can do. That's why the production builders work closely with the manufacturers to try to work on a program that is efficient, where they can buy the product that goes into their home at a less price, or to get some kind of rebate coming back to where they can live with it. It's a very difficult situation. You just take Southern California, for example. The average home in Southern California is about $800,000 or $900,000. 50 years ago, it would sell for $10,000. That's partially due to inflation, of course, but on the other hand, it's just a matter of cost and codes and regulations that are being required for that builder to build, in order for him to even build the home so he can sell it.
So, when it comes to implementing these new systems, what challenges might arise during the installation and how could they be mitigated?
It's a very simple installation for on-demand control systems. All you're really doing is changing the way the plumbing layout is, so it's more efficient to the hot water being distributed to individual fixtures. The economics of it are not that expensive when you get right down to the material itself. It's fairly inexpensive. In most cases, they're very simple to retrofit as well. So it's not that expensive, but when you add a few $100s on top of what they're already buying, it's kind of a choice. When somebody goes to buy a new home, like a family goes to buy a new home, the wife always looks at the aesthetic value and what she's going to be able to get to put in that home, because that's how she thinks. The man, on the other hand, might think of the energy values, dealing with solar. Do I need solar? Am I buying an electric car? How do I plan that? Those are the things that are kind of decisions that the families actually have to make. But the initial cost of installation of these systems is extremely reasonable. And with one caveat, they have a payback in almost every case within 2 years, 2 to 3 years. Whatever they were doing before is going to pay for the product that they put in. So anything after the 2-year period is going to be bottom line profit, if you want to look at it that way. It's going to be bottom line savings, because they've paid for it already over that short period of time, because they use it. And they use it because it's a convenience to them. They like it. So the real key here is to be able to, for that homeowner that's buying those homes or moving into those homes or have one currently, is to look at the long-term relation. When I say long-term, less than 10 years. In other words, 2 to 3 years, they're going to have the system paid for. Now, the other question you didn't ask me, and I want to bring it out. We know for a fact right now that the on-demand control systems that are in the market that were built in 1995 are actually, over 90% of them are still operating, which means that now you got longevity with no maintenance issues. It's because of the way they're designed. And that's really important to the homeowner, because he kind of puts it in and forgets it. He doesn't have to worry about the maintenance issue or replacement issue.
Now, how could design professionals ensure compliance with local regulations when implementing hot water recirculation systems?
Well, the codes and regulations are in place actually right now. Nationally, they've already regulated on-demand control systems for virtually everything from apartment buildings to multifamily buildings, commercial buildings, residential buildings. But it doesn't always mean that that state has to do it. They have options. And the reason why they don't make it mandatory, because they know in some areas, if they made it mandatory, it may be a downside for the economic growth of that area when they start adding costs to the buildings that they're building. For example, you take areas like North Nevada, like the Reno, Nevada area, for example. That area has gone from like $350,000 on an average home to over $600,000 in the last 5 years. That's the problem. Your income, or the average income of the people living in that area, their income didn't go up that high. So, and that's the biggest investment that virtually every homeowner makes, is going to be in the home that they live in.
Yeah, absolutely. So definitely some cost benefit considerations potentially in there. What are some common misconceptions that designers might have about hot water redistribution efficiency?
There isn't a homeowner that I've talked to over the years out of 7 or 8 countries that I visited, and I've actually looked at probably over 40,000 homes being built in different countries, including the US and Canada, because I wanted to see what they were doing and how they were doing it. And the problem is pretty much the same everywhere I go. It gets a little worse in some areas versus others. I think everyone wants to do the right thing, and water is, as much as water becomes more expensive and less valuable, meaning not less valuable, but it's less available to you, and it's going to cost you more to use, as well as your other utilities like electric and gas and everything else that you're going to have. I think everyone wants to see us make a better home and design better plumbing systems and design better distribution systems. But the problem's going to be on the costs that go with it. But as our energy costs go up, the average homeowner is going to realize, because of social media, by the way, because now they can go to the internet and get almost anything you want, and you can find almost anything you want. The only problem I find with the social media, that what you always find isn't necessarily work the way they tell you it works. So there's a lot of supervision, I think, that has to be done to be able to let people know that what they're reading actually does what it says it does. But I think the general goal for all of us is, whether from my point of view or from the builder's point of view or the contractor's point of view, is to make a more sustainable home for us to live in and have a better environmentally clean air issue, cleaner water, cheaper electricity. I think we're all looking for the same thing. It's just, how do we put it all together to get there?
How does hot water recirculation systems integrate with other potential building systems to promote that overall energy efficiency?
I think it's going to be definitely the thing of the future. It's already happening in a number of U.S. states. Um, I just heard a report the other day that the state of Georgia, if you build a new home, you have to put in a recirculating system in the new home, meaning a dedicated return line. Now, the reason for doing that is because you're going to be closer to all the hot water fixtures. What they need to do is to make sure all those homes are going to have controlled on-demand water distribution systems. So you're not going to run that hot water 24 hours a day. That's where you're going to lose your energy loss and get your maintenance issues, are running water constantly for any period of time. So we're getting there in bits and pieces. And I think the near future is going to dictate that these sorts of products are going to have to be mandated if the builders or if the contractors aren't going to do it themselves, then they're going to have either be incentivized to be able to do it, or they're going to have to be mandated to do it. One of the two. But all of them want to do it. Nobody doesn't not want to do it. They do want to do it. They just don't know how to get there.
And does user behavior play a role in the effectiveness of the hot water recirculation systems?
The key to anything, and you can ask your parents the same thing, or you if you live in a home and you turn on a shower and it takes forever to get the hot water. The customer satisfaction and the convenience is unbelievable. They don't think about it from the water savings or the energy savings or the air pollution savings. They think about it from the convenience. They no longer have to wait. In other words, when they've activated the system and the water gets to that fixture location, they turn it on. It takes 3 to 5 seconds to get hot water. They don't have to wait. They don't walk away and feed the dog and go mow the lawn or whatever else is out there. So the solution is absolutely something that is a convenient to all homeowners.
Fantastic. As we wrap up, just a final couple of questions here. What do you see the future of smart water and energy management evolving into when it comes to architectural or engineering design?
I believe that it'll actually be a mandated way to go. I think it's just going to be a standard for the industry. If you look back, and I know you guys probably haven't, but a few years ago, builders never put in anything but single pane windows. And they found by putting dual pane windows in that a lot of energy was saved. They didn't lose any heat or cold, depending on whether it was summer or winter. Eventually, because of the energy efficiency of it, that become mandatory. Now, you would be lucky to ever find a home that didn't have a dual pane or a triple pane window in it for that very reason, because it not only works, it's important to have because of the energy situation that goes with it. So I believe that all of the codes and regulations, including the industry itself, are going to morph towards making these kinds of products and having them more available, readily available for all buildings. And they're certainly not going to get any complaints from the homeowners because they're adding the convenience plus the savings to them both on their utilities.
And do you have any tips for design professionals to be able to effectively communicate the value of water and energy efficient systems to their clients or developers?
What the contractors or the builders have to do is to make the homeowner more aware that they need to put something in like this, not only for their convenience, and they got to start with the convenience side because that's the first thing the homeowner doesn't want to do is wait for hot water. The largest, most single complaint that homeowners have moving into new homes is out of the top 3 complaints is waiting for hot water. Why am I waiting for hot water? What did you guys do to my home that I can't get hot water? It takes me 2 or 3 minutes. So the convenience factor is very critical, and to start with, from the builder's perspective, to sell this kind of product, and then pass on the fact, oh, by the way, you're also going to be saving energy, water, and reducing the air pollution. Most people don't even know how to reduce air pollution. All they know is they hear about it every day, but they don't know what they have to do to save it, nor do most of them care. Water side, they care about. Energy side is a little more difficult to explain because all you can do is say, you're going to reduce your energy bill by X amount of dollars. Oh, okay. Water savings is another thing. By saving water, you're adding convenience because you're not waiting for that hot water. So they can relate to hot water and the convenience of not getting it.
And Larry, what's some final words of wisdom you would like to share with our audience today?
My word of advice is when you start to do a design on whether it's a model home, new home builder, production builder, custom homes, whatever, that you consider the fact of plumbing it correctly to take a benefit of meeting hot water within a few seconds to the homeowner when he goes to a fixture. And that's not difficult to do. They just got to plan it in the design. And that would be my word, is start looking at these products out there, getting the information on them, making sure you fully understand how they work, fully understand what it's going to cost to do the installation, and be able to explain to the people that you're selling your product to, your architectural drawings or engineering or whatever, that they understand that it's going to have a significant payback in a very short period of time. More important, it's going to have a long life of 15 to 20 years. Because that's one of the things that we don't recognize anymore as consumers. We don't see anything that lasts 15 to 20 years. We don't expect it to anymore, because typically it'll break down or something goes wrong. So if they get something that works, that creates a convenience, that lasts a long time, they'll be excited about that.
Absolutely. Larry, I really appreciate you sharing your knowledge and insights with us today. Thank you so much for joining us on the Spec Shaman podcast.
Thank you for listening to the Spec Shaman podcast. If you enjoyed today's episode, please subscribe to our show and leave us a review. A huge thank you to our guests who made this show possible. Building product manufacturers who want to increase their specification opportunities, please visit specshaman.com or ronblank.com. Thanks all for this episode, folks. See you next time.